All right, we're going to continue working on sorting our lists, and this time I'm going to show you some sorting algorithms and how to use them to create what you need to in this lab. Again, this lab works a little bit different than the other ones. In some ways, once you understand how to do this, for lab 10.1, like the first problem, the next two are relatively easy to do. So we're going to go over to Google and we're going to take a look. This will be posted in Google Classroom or whatever system I happen to be using at the time. And what I've done is I've created these nice algorithms. Maybe it's a while since we've used algorithms in this class, um, but you might remember all the shapes and that kind of thing that can happen. Um, Instructions for how to do code, decisions that get to be made in your code are the diamonds, and the rest are instructions. And you'll see that when you do this kind of thing, this is a loop where something's going around and again and again and again, and eventually it gets out of that loop and it um, it ends. So what's going to happen here? Well, you might look at this and your eyes might glaze over and you don't understand what's going on. What you might find is that this pseudocode, which is another way to show an algorithm, this is not Python code. This is something when you look at it, you're going to see some words like for, if. Um, you're going to see some words that you recognize, but it's not going to completely make sense. But the good news is every line of this pseudocode is a line that you're going to program, with the exception of two things. These lines that say next. Some languages you actually have to type in the next J, but in Python it does it automatically. So you don't have to worry about the next lines. But everything else is going to become a line of code. And all you really need to do good on this assignment is interpret those lines of code and create them in Python. And I'm going to do the first one basically with you and for you, except for one little bit. So if I, yeah, I'm trying to figure out how I can fit both of these things on the screen at the same time. Oh, there we go. I'll move this over, and I'll move this like over here. And again, you can follow what happens here in the shapes if you're a little bit more visual, but I find most people like this. They're like, hey, this is almost like code I understand, so I can do this. So this is supposed to be the selection sort. I think on your sheets, I may have told you to do the insert sort first, but it doesn't really matter which one we end up doing. So let's just say in my code, I do a selection sort, and I wanted this to happen on a function or on a list we're going to call, I can't use the word list, so I will call it, I don't know, numbers, because that's what we're working with. Okay, I'm just cleaning up some things from my last example here. Down here, we still have a list created. That list is going to run, it's going to create, append 100 things to the list, which are numbers. It's going to print that list to the screen. Then what's going to happen, we're going to change that. Perhaps before you print the list to the screen, you want to say, unsorted list. I like to capitalize in this because there's so many numbers floating around that shouting out it kind of helps a little bit. Okay, so we're going to print the list. Then what we're going to do is we're going to run the selection sort on that list. and then we're going to print the list again. Except this time, before we print the list, we might want to say selection sort activated results. So that when we print this list the second time after we get this done, we should have a list that prints out in order. So up here is where we're going to create our algorithm. Well, we're going to implement our algorithm. Okay, first line of the algorithm. For I, strange arrow sign, 0 to upper bound do. Okay, I recognize for I. I don't exactly know what the rest of that means, right? For I. Well, how do we write in Python a for statement? This is supposed to be written so any computer programmer who learned any language could understand it. So we have to interpret it a little bit. Well, it says to start at 0, which is something that we can do. So we can say, okay, we want to start at 0, and we want it to go to upper bound. Okay, so what does that mean? The upper bound is the number of items in our list. So we know we have 100 items in our list, so we could say, we want to run this 100 times. So I could put the number 100 there. Another option that you would have is you could say, you know what, I want it to run the length of the list. And the reason we do this is because later on, maybe we want to play around and change how big our list is, and this can tell us exactly the length of our list, and so we could say, hey, just do it that number of times. If the list has 100 things in it, do it 100 times. If the list has 2 things in it, do it twice. Whatever. We're all good. So that's the upper bound of the list. That's what this means right here. Okay, and then it says do. So that's basically saying, what do I do in this for loop? Well, this is an easy line. Smallest equals I. I don't understand why, but we're going to create a variable called smallest. And we're going to set it equal to I. If you think about that for a minute, that means, I is a nice number. I is going to start at 0, so smallest is going to start at 0. Okay, sounds good. Aha! The third line is another for loop. Now this time we're using J. Interesting. It's not going to start at 0 like this one does. It's going to start at I. So wherever this loop is also going to be there. So let's write that out. For J in range I to the upper bound of the, upper bound, I just did that, so I'll just go that again. Okay, I'm still not understanding this sort function, but hey, that's okay. Look at this, an if statement. If whatever the array or the list is that we're looking at, we're going to look at position J. And if J is less than the position of the smallest, which is this one, then the smallest is now going to equal J. This is a lot like what we did when we were trying to figure out what the lowest number was in our last lab. We want to say, so far we know our smallest thing is this, and hey, if our smallest happens to change, then we want to track that. So we're going to say, oops, not array, if numbers at position J is less than the numbers at position smallest, then the smallest is now J. Notice we're not saying what the number is, we're just saying if that position, look up that position and compare and see if that position's number is smaller than, well, if this new thing we're looking at is smaller than that position's number. Then just remember that, like, hey, the 5th item is the smallest one. Remember that. Okay, we get down here, we have next J. Next J we don't have to do. We get to next J by just changing our indents so that we're lined up right here. In fact, I want to go down a little bit just to make it easier. Huh. I don't know why, but it was not lining up quite right. Here, I'm cutting myself off a little bit. I can do this. Okay, swap. All right, now this is where it gets a little bit interesting. I'm going to type it in here, and I might make a separate tip to understand how to do a swap. Basically, what's happening is we want to change the position of the list that we're looking at position I, which remember is a constantly changing loop. We want to change the position with I with the position of the smallest thing. What we're trying to do is find the smallest thing and put it in the first position. Then we want to go through and find the next smallest item in the list and put it in the second position. Then we want to go through and find the third smallest thing in the list and put it in the third position. And that's why it's a selection sort. What this is trying to do is it's trying to look through the list and select the smallest number and then say, okay, I'm going to put that over on the left side. And then I'll find the next smallest number and put that next to it. And I'm going to rebuild my list based on every time I'm going to select the smallest thing from what's remaining and put it back. So in order to do a swap, here's what we have to do. I thought about making this a whole separate function so that you could only do it once, but it actually gets a little complicated to make it a function, so we're just going to do this. We're going to set a temporary variable up. And we're going to say, okay, that temporary variable, we want to remember position I. Then we're going to forget position I and make it equal the position of the smallest. And then we want to take the position of the smallest and make it equal the temporary. What we just did, and again, I'm going to explain this in another one, was we basically did a little swap between three different things. And we had to use 3 in order to swap 2 because we had to temporarily store something. So if you get that, that's awesome. If you don't get it, look for another tip that explains swapping. So, look at this. Next I. Again, we don't need to do next I. We just need to stop indenting. So that's the end of our function. It does a for loop. It sets I to be whatever it's currently looking at. It goes through the loop, through the whole thing, and decides which is the smallest number and finds it and sets it right here. And then it takes that smallest number and it positions it at the first spot in our function. In our list. When it's done, it's going to come back down here and it's going to print it. And because we know that whatever we do up here affects our list down here, it should be sorted. So I run this. I say okay. Here is my unsorted list, a bunch of numbers. And sorted list activated. Here's the results. Well, the lowest number ended up being a 3. Here it is. So it didn't randomly generate a 1 or a 2. And then a 4, 5, 2 6s, 7, 9, 10, 11, 11, 12. Does this look like it's in order? What you want to do is you want to take a quick peek through it and see if anything didn't work out. But it's looking pretty good to me. Here at the end, turns out there was 3 97s and no 98s, 99s, or 100s. So I got the beginning of it good. I got the end of it good. And on a casual glance, I see no errors in it. So my sorting function must have worked, which is awesome. Hurrah! Now, that was the selection sort. Down here is how to do an insertion sort. It's a slightly different piece of code, but it has a for loop. It has a statement. It has a while loop. It has an if statement. It has another swap, which every single one of these will have. It has a little j equals j minus 1, and that's all it is. If you can code that, you can do a function that does an insertion sort. You come down to the bubble sort, and the bubble sort has uses a boolean. Okay, well, swap equals true. While swap equals true, we will then turn swap to false. Kind of strange. Uh, a for loop, an if statement, a swap. This little variable we use called swap is going to equal true, and that's it. 1, 2, 3, 4, 5, 6 lines of code. So 6, 7. This one's got 1, 2, 3, 4, 5, 6. And yeah, you do those and try to implement them and see if they work. And that is basically how you do this entire program. We'll take a deeper look at how to do the swap and what's going on there in another tip.